I was just about to jump in with a question. Can you hear me?
Yeah.
Yep.
Yeah. That you're talking of FPGAs, and I guess a singular term is the bit stream that's programmed to it. Can you partition? So while the FPGA is running or configured for one task, you can reprogram and start another.
Sorry,
or are you programming the bit stream every time?
That's the question. I'm trying to avoid reprogramming every single time. So that could be a case where you want to do that. For example, is assigning a device directly to an instance, let the instance do the programming or something like that. In that case, it gets reprogrammed all the time.
I lost the meeting from there. Could you just follow, quickly go back? Sorry. Repeat what you...
Mike, can you repeat your question?
Sorry. Yeah, sorry. Yeah, I based on the previous meeting, you were talking a singular for FPGA. So can you partition an FPGA to two virtual functions, for example, and then program those individually? Or is it when you do the bitstream programming, you're completely wiping the device, reprogramming it once? Or is there some kind of executive that sits on the device that enables different areas of it to be reprogrammed?
Yeah, so Xilinx, I mean, that's a difficult problem to solve. I think that Intel has a solution for that, but that's not something, there's a lot of security, memory, privacy issues that it's going to take us a long time to solve that. So not currently. I don't know, Sundar, if you want to comment on the, LPAE flow.
Okay. If you're asking in general, Michael, the answer is yes, there could be multiple partial reconfiguration regions within FPGA, and you could program one without necessarily affecting the other region. As Dutch points out, you have to be careful about the security aspects of that to make sure that the bit stream you're programming is going into the right region and not affecting somebody else. So I think architecturally, the flow you're trying to come up with tries to enable it. In terms of implementation, may vary from vendor to vendor. It may also be something that's phased over time.
Okay, that's very interesting. Thank you.
Yep.
Yeah, I think it's like if you have, you can program a VF, but if you have a VF, you can't program into that VF, like basically. And you can do that on an FPGA, but it's the burden is on you to actually separate the logic.
Okay, so back to the topic. So shall we all agree that we could apply a layer in Cyborg so that no matter is a pre-programmed or programmable FPGA or other accelerators, that you can define a layer that to enforce certain policy, I guess. So maybe the default layer could set to do nothing if the reprogramming is pretty fast, or you can define at least layer to enable user to choose the or say orchestration to choose certain acceleration function with any concerns, whether it's security concern that you don't want to reprogram it or other issue. So would that be a conclusion okay for everyone?
Well, I'm not sure. Yeah, I don't know. Sundar, sorry to cut you off there. I don't see it. I just don't see it being practical. Like the way that it's being described, that's the thing that I'm struggling with. Because how is Cyborg? So after the placer goes out and gets the list of FPGAs or whatever, I guess so what happens? The placer goes in and selects the host with FPGAs, and then the layer goes and chooses which FPGA it wants to put the instance on. Like, I'm not exactly sure how then it feeds back to Cyborg, and then Cyborg feeds back to displacer, or what is exactly happening here?
So let me put it this way, right? So in the flavor, we ask for all device types which can potentially support a given function which we want, like let's say video transcoding or whatever. The actual function ID goes in the extra specs of the flavor. So when you go through placement API, it's going to look only at the resource class you asked for. It's going to return you all the compute nodes which have a device type, but not necessarily the particular function.
Right.
Okay. So that list comes back, and no one now starts calling your filters and weighers. The PTG flow, as I understood, was that we would have one weigher which will say that I got this list of all hosts. Now I'm going to look for those which actually have the functions being asked for. So it's going to rank the hosts. It's going to prioritize them based on which ones already have the functions, which ones don't. So once another function will bubble up the top, once without will be the bottom. So you're still free to pick a node. I mean, Nova could still pick a compute node which does not have a function. You still have to handle that. We're more likely to get a host which already has the function. So we're reducing the need for reprogramming.
So, okay, so what does it use? Because right now we're identifying bit streams by UUID. So are you saying that the subsystem ID is going to be used? Like you said, function ID. So we have device ID and subsystem ID. Are you looking at subsystem IDs then for this weighing, or I'm confused as to what's happening? Because if you put in the extra spec, I want an IPsec. Cyborg has no idea what an IPsec is. It can only take a list of UUIDs, and it could say, okay, these UUIDs match this, extra spec tag, and therefore I'm going to look for a bit stream or a shell or whatever that's programmed with this UUID. And if it's not programmed, then I'm going to flash that UUID to the FPGA, if I can. I have to take a resource that I can flash, obviously. But I don't know exactly where the thing comes. How do we? I guess we could set a not programmable option, and it's like a fixed function accelerator. But then we're mixing these things. We're mixing the case of a fixed function accelerator and reprogrammable accelerator together in some sort of hybrid that's not clear.
Okay, just taking one thing at one time, right? So you raised many points. Like first, into the function ID, it's whatever the vendor says it is. The vendor is the vendor driver provides the function ID to Cyborg, right? That's how Cyborg gets it. So what Cyborg is doing is to match what's requesting the flavor to what the vendor says is already available. So it's a completely generic mechanism. Cyborg it's not, of course, vendor specific. But basically, IDs are coming from the vendor. So there is no link there. And the broader question of, do you want to mix pre-programming or fixed function hardware, as you put it, with orchestration-driven programming? In general, in the cloud, you'd want to do that. You would have models where either something is already pre-programmed, you don't want to redo it for security reasons or whatever, or you could have a model where you're assigning a device to the VM and letting it do the reprogramming with all the associated security concerns again. And third model would be that the orchestration itself handles the programming for you. So the user simply asks for a particular function and he gets it. If it's not already available, the orchestration do the reprogramming as needed. So this gives you all the mechanisms. Again, we are not trying to say what the cloud operator's policy should be, right? They may choose a simpler model like pre-programmed alone, or the AWS flow alone, and so on. They could choose any one of those policies, modes of operation. At the Cyborg level, they're only giving mechanisms which they can use any way they want.
So we're specifically addressing like option 3 here, I guess, right?
Yeah.
So, but first tell me, is your function ID, what is that? Is that a sysfs thing? Is that, what really is that? Is that a fixed, is that related to the bitstream? Does the system know? Is it a UI? What is it?
At the simplest level, if one bitstream is doing only one thing, you could say bitstream ID is the function ID. You could have a more sophisticated use case as well.
I think
the simplest level, if you say that bitstream is doing one thing, it's fairly simple then.
I remember we discussed the to put a sort of a translator layer or sort of a remapping layer from user understandable function description to a bitstream ID sort of thing, right?
Yeah, we can have like combination of a string describe the functionality and then the UID associated with the accelerator.
Isn't that also useful to map it to GPU?
Yeah, so
that's kind of what I'm going off of, but I'm just not exactly sure how we do the scheduling and weighing of that, you know. So I think that's where where we're gyrating on this.
Yeah, so I think for me a broader use case is, for example, say machine learning, right? And we have Cyborg manage several ASICs that customary built for AI model training. Now a user might say, give me an acceleration resource that best suit for the Inception version 3 model, right? So, well, the question will be parsed like with a higher level, but whatever, Nova will like choose the host with ASICs on it, and maybe Cyborg could have the weighter to further like more to further have the, for example, the ASICs have like the PE number larger than 50, let's say, better do the job for that AI model. So that will be another like example in a broader sense for accelerators.
Yeah, but an ASIC is going to have a fixed device ID, and they'll be
and you can have like
different.
So you can, as an operator, you can have multiple types of ASICs, right?
Yeah, but they would all be unique, right? If they're PCI devices, not that they are, but
exactly. So
but there's no reason to. That's the thing with an FPGA, right? They're all an FPGA is all they're blank until you program them, so they could be anything. You can change what it looks like, with a bit stream.
Yeah, but like each FPGA card also have like constraints on its I/O bandwidth, etc. Right? Different FPGA cards might have different network throughput. So if I have a hybrid acceleration resource pool that I have FPGA in my disposal, I also have some customary ASIC at my disposal. So at least I think it would be like natural for me to have a weighter that could tell me, for example, if I want to train an AI model or do a genetic analysis or do a NFV, EPISAC, whatever, which one would be preferred for that workload, for that type of workload.
Okay, I think we're talking about slightly different things here. However, I think you're talking about some matrix or KPI for the capability measurement, and the wearer needs to know this and give the user the most appropriate one, right?
Yeah. So where would be the one that like at the lowest level to reflect that? But yeah, we will also, like you said, have something like translation, whatever on the upper level. So
I think in my opinion though, right? Because in Nova, you shouldn't really care about all the capability KPIs, because this is a purely platform, like a PaaS level service. And Nova is really not meant for that.
Yeah, Nova.
but Cyborg could provide another set of API that takes this capability, like the capability KPI, and user can go and call the service to find out what's the most suitable bitstream ID for them. And then the user takes, or the orchestrator takes this bitstream ID and asks Nova to program for it. So Nova shouldn't care the capability KPI of certain function.
Yeah, absolutely.
That would be way too complicated for Nova.
Yeah, Nova is designed for general computing, so it's not suited for Nova.
Yeah, so the Nova just takes whatever bitstream ID that the user is asking, and then throw it to Cyborg, and Cyborg prepare it for it. And the where itself is, I think what it does is not doing the capability KPI. What it does is optimizing the resources that, for instance, you have 3 hosts that's, let's say you have 3 hosts that's suitable for loading this bitstream, and then one of them has the bitstream already loaded. I think what we're trying to optimize here is, instead of giving the other 2 that's not loaded, we'll give the user the one that's already been loaded with the bitstream. So I think that's what we're trying to optimize here.
And so in that flow, we have to call Cyborg twice, right? Once for the where and once for the programming.
The programming itself would happen.
Go ahead.
Sorry if I interrupted, please. Yeah. I was clarifying that you are not calling into Cyborg in the controller for programming. That would happen in the compute node after a particular node is selected.
Yeah, that's the problem when you put where in Cyborg. You have to call it twice at least. Because the first time you call it, the host is not determined, and then yeah.
Why would you do the second time?
Are we supposed to get all the data to the one of the database and try to access from there? I think that was the original design, correct?
Well, there's a Cyborg database, but there's also a database called placement in Nova that tracks this some sort of information.
Yeah. So what I suggest is I leave an action item for sender to just propose a spec.
Okay.
On this to the Cyborg spec.
Sure.
And we could just review it on Garrett.
Okay. Sounds
okay.
good.
So
yeah, that's great.
Yeah, that's great. Okay, that kicks off the second main agenda item for today, the task assignment. So, Xiaohe, is Jinghan still here? Or Xiaohe, are you still here?
I'm here, but I think that Jinghan is in sleeping.
Okay, so I think for the quota and multi-tenancy, I think the action item for Jinghan is, and you guys, if you want to help, I think first of all, we need a client desperately. The curve thing is just not gonna fly. Okay, so we'll need a new repo for the Cyborg client using the OpenSet client. So every major modules using that now. And the quota engine, Jinghan mentioned, I think this is great. But also experiment with the Oslo limit. for the quota. So I talked to the Keystone PTL later. I think Friday on PDG. So okay, thanks, Alex. So the Keystone team has finished all the limit API design and code also in Queens, and in Rocky. One of their goal is to provide it as a Oslo library, so that each like service want to implement the limit API, they could do it like through Oslo. So I think we should experiment with also limit thing for the cyborg quota design. Okay.
Okay.
So we can talk about details later. The programmability, so that would be Li Liu. So programmability, so spec
I
first.
will. I will put up a spec first for you guys to review it, and then start implementation after that. What's the is there any deadlines, ETAs for this? Like
yeah, I will talk about later.
Okay.
So also Jinghan needs a spec. Okay.
Okay.
I forgot to mention that. And what the? And more drivers. So Dutch, can I put you for the Xilinx?
Yeah. Yep.
Yep. So Xilinx driver. And Michael, you mentioned the ICE something the.
Oh, Project iStorm. That's very low-end FPGA, which possibly could be useful for a demo. Blinking lights.
So would you like to provide a preliminary driver for that?
Not at this point, no.
Okay. Okay. Then
I'm not clear to submit that level of code.
Okay.
It's complicated.
I think we'll discuss with ZTE team on the clock driver maybe next week, since that item wasn't discussed clearly during the PTG meeting. Okay, next up.
Maybe next week.
Yeah. So next up, the Nova Cyborg interaction. I think one is the Sanders spec. Another, I think I put it to Julie for the OSACC. And another one is for Yumeng to I think it is a good time to have a dedicated spec folder.
Yeah.
Okay. So create the, just contact the infra folks. Create a repo and polishing the docs. The docs are shit now. So, okay, metadata, that's also Lidio, right?
Yeah, I will put up a spec.
Okay.
Yeah, because this one actually ties to the
Yeah. So let's see the release schedule. So for the Rocky, we're gonna do it like the core project. So we're gonna do with the milestones. So as usual, we'll have 3 milestones. So each team has a different, for example, Keystone, they freeze a lot later than Nova. But I think we should follow with the Nova pace, basically. So we'll target the Rocky 1 for the spec freeze. Okay, so that means by the week of April 20, we should have all the specs up, at least all the specs approved. That would be ideal. Okay, so then with the summit, drink, talk. Rocky 2, that would be the June. Okay, let me see the Queen's one.
Yeah.
Okay, so for Queens 2, for Cinder Manila team, they have the driver deadline. So let's slate the drivers for Rocky 2, which will be the June. Get back. So Rocky 2, the second week of June, we should have the driver submission freezed. And then for Rocky 3, that will be feature freeze. And again, for RC, that means code freeze, right? All the development hard stop. So for all these action items, I think there's some exceptions. So for Jinghan's also limit experiment, I think we should push it to Rocky 3 because there's a dependency on the Keystone team side. So we should defer that to a later date. And for metadata, Liliu, do you think we should also maybe delay it to Rocky 3 so that you can focus on the programmability?
Yeah, I can try, but because the programmability relies on something, some aspect on the metadata.
Okay.
But at least I can fake something for now.
Okay.
But I think the programmability has some higher priority for so I will start with that. But I will put the spec first. That's I think.
Okay, so
before the coding.
Okay, let's say spec freeze around April, the week of April 20, and driver freeze. Driver freeze is June 8. And feature freeze. Feature freeze is July. So the also limit could be an exception. Okay, other than that, we'll have 3 new repo created, the Cyborg client, OSACC, as well as the Cyborg spec. So these new repos should be created as soon as possible. Okay.
Okay.
But OSACC could be have some delay. Okay, Okay, this is just like temporary assignment. So if anyone has the bandwidth to help, please feel free to do so. So on my side, I will also I have been in contact with the NVIDIA team and also having discussion with Jiang Hua about GPU support. So if that becomes clearer, maybe have a discussion next week. Maybe we'll add GPU stuff also in the Rocky. Okay, so any other questions regarding the task assignment and these deadlines? Yeah. Please help to review any change. So yeah, I have hook up the status bot and Garrett bot with the channel. So if you can find what do you call it? Find the client, IRC client, stay on the channel, you will see all the patches notifications. Julie is still here. Okay, let me see the chat. Okay. Okay, if there's no further questions, then let's start working. Rocky already started. Okay.
All right.
Yeah, let's conclude the meeting. We have very good 2-hour marathon meeting today. Thank you very much.
Thank you.
Yeah, thanks, Howard.
Yeah, thanks
Thanks,
everyone.
very good.
Bye.
Have a good
Yeah.
night.
Yeah.
Stay early, stay late.
Good night.
Okay.
Remember to close the meeting.
Oh, yeah.
Okay, bye-bye.
Okay, bye-bye.
Bye.
Bye.